At this point, we've covered the alpha hemolysis part of the streptococcus. We've covered the viridin, streptococci, the pneumonia. We've covered the beta hemolysis part of streptococcus. We've covered S. agalactiae and S. pyogenes. And now we move on to the gamma hemolysis part of streptococci, right? For the gamma hemolysis, we basically means there's no hemolysis. It's this part, right? So there's no hemolysis, there's no RBC destruction, there's no color change, and there's no clearing. This is for group D streptococci. D for dog, right? So we know that the beta hemolysis was the one with the group A and group B streptococcus. It is helpful to remember that in the gamma hemolysis, the streptococcus which we are seeing is usually called the group D streptococcus, right? So that is something you can remember for now. Now let's study the gamma hemolysis in more detail. Now, gamma hemolysis, these are the ones that are obviously gram-positive cocci. They were catalase negative. That's why we knew that they were Streptococcus species. And now they're group D Streptococcus because they were gamma hemolyzed. There was no hemolysis happening. Can these group D streptococci grow in bile? Yes, they can. Let's see how. So the bile esculin test, I'll repeat it here. The positive ones are group D streptococcus, right? So example A, the ones that can dissolve the bile, right, are basically group D streptococcus. And example B is negative. This one, the control one, is group B streptococcus. B for bat. Group B does not get hydrolyzed by the esculin in the bile. So the selective agent bile inhibits most gram-positive bacteria. Esculin in the medium is hydrolyzed to escalatin and dextrose. The escalatin reacts with ferric chloride in the media to form a black-brown color. So this does when you get hydrolysis with the bile, that's basically group D streptococcus. You can remember that, right? So does it can grow in bile? Yes, it can. And now to further differentiate between the Enterococcus species and the S. bovis species, we do a 6.5% NaCl test. Let's look at this. Now, for the Enterococcus identification, in order to know if it's Enterococcus or not, we do the 6.5% NaCl growth test. Now, what is this 6.5% NaCl growth test? You must know that the intestine basically has a really harsh conditions, right? You have these acids and whatnot in the intestine. So for the intestine species to survive, they must be able to survive very harsh conditions. So it is helpful to remember that the Enterococcus species can tolerate 6.5% NaCl growth, but Streptococcus species cannot, right? So the enterococci intestine are very tough organisms. They can tolerate high salt. So in growth of 6.5% NaCl, you get a positive enterococcus species. But the S. bovis cannot tolerate high salt presence and there's no growth, right? So once you do the NaCl test and a species survives, you know that it's an enterococcus species. If the species does not survive, then you know that it is strep bovis. Now, further on, we do a pyruvate fermentation test. The pyruvate fermentation test helps us determine whether something is Enterococcus fecalis or Enterococcus faecium, right? That's why we do the PYR test. Again, I'm revising this again. The PVR was you don't need to know this, but it's pyrrolidonyl Arylamidase test. It's a very difficult name, and you won't have to know how it is pronounced, but I'll punch it here for anybody who wants to memorize this. Basically, the PYR test detects an enzyme that breaks down the PYR substrate. Enterococcus has a PYR enzyme, but S. bovis lacks that enzyme, right? So S. bovis is PYR negative, right? And Enterococcus is basically PYR positive. So this is here. You know, a positive one will be an Enterococcus. They can be these species. And S. bovis lacks the enzyme, so it will be PYR negative. That is something you should know. Um, I'm going to post a picture here, a table here, if it's possible, just to remind you that S pyogenes, we just revised it in the previous video. The S pyogenes, so if I talk about the organism, And the PYR test, I want you to know that the Enterococcus species was PYR positive, right? And the group A strep, the S pyogenes, was also PYR positive. Let me just fix this table so you will be able to understand. And the S bovis is PYR negative, right? Can you appreciate that now? Now the table looks fine. So organism PYR positive or negative. Enterococcus is PYR positive. Group A strep S pyogenes is also PYR positive. We saw it in the previous video. And S bovis is PYR negative, right? That's how it looks like. The negative, the positive one becomes red. Enterococcus and group A strep S pyogenes is also positive. Now, a little bit about what this strep bovis and enterococci species are. Now, first of all, let's go to the enterococci, the ones that were surviving the 6.5% NaCl, and they were also surviving the wild test. Entero comes from intestine, right? Fecalis means feces, and strepto means twisted chains, and coccus means like a berry. So it tells you a lot of things about itself by its name also. The Enterococcus fecalis basically is very common. It causes UTI, it causes endocarditis, biliary tract infections, and subacute. I've already mentioned subacute endocarditis. It also causes some intra-abdominal infections, right? And the Enterococcus faecium, the faecium part, this Enterococcus faecium, this is very drug resistant. It's associated with hospital-acquired infections and vancomycin-resistant enterococci. So it's very dangerous and it's a very resistant infection. It's very difficult to get rid of it. Why are enterococci important? They're naturally resistant to many antibiotics. That's a common exam point for you. So UTI after catheterization, if you get a gram-positive cocci and it's PYR positive and it can grow in 6.5% NaCl, always think about enterococcus. Yeah, that's something for you guys. Streptococcus bovis. Now let's go to Streptococcus bovis. This is now called mainly Streptococcus gallolyticus. It lives in the colon, right? So let me put the punch the name here. It's important because the S bovis bacteremia is associated with colon cancer. That's something you guys should know. This S. bovis bacteremia is associated with colon cancer, right? Very famous exam association. Why colon cancer? Because colon cancer disrupts the colon wall. The bacteria then can enter the bloodstream. So the patient develops bacteremia and endocarditis, and later colonoscopy reveals colon cancer. So whenever you get someone with S. bovis, you must always screen them for colon cancer. Okay. Now, classical exam vignette for colonoscopy, an elderly man shows up with subacute endocarditis, blood cultures grow S. bovis. What's your next step? You always get a colonoscopy done. That's a vignette. So, an elderly man comes with subacute endocarditis, the blood cultures grow S. bovis, you get a colonoscopy done. Always remember this, right? Even though the video is short, I'll stop it here and I'll start the next video with the next species. Okay.